Day. So let's just give a recap of what we were doing yesterday and what we want to do overall. So yesterday we were trying to just build up the initial structures for making an actual request to the which.io. So we created this structs based on the specification, the description table, the avail and the used, and we also managed to actually allocate them. As it, yeah, we have allocated all the three of them, and we are passing down it into the virtual object because also these three values are supposed to be physical addresses. So I guess that's why I have passed them as physical. Maybe it's also better to pass is both the things because only the device will access it as physical and we will have to access it through virtual. So I believe we can add both the things. Let's just put that here to do. What do we want to actually put? Yeah, but let's just say that in general we are just trying to build up all the structures that are needed, and in general we want to make write request to which.io saying that block 100 needs to be written with certain number of bytes. This is our initial example that we are gonna make it work. After that we can think about improving it and integrating it with our VFS layer and stuff like that. But right now our only goal is to make sure we have a write request sent to which.io using the events, and we properly build up all the values for these structures, and we make that block work. That's how we're gonna do. So yeah, let's continue. I think we can just directly do it here. Let's see. 2. And I can change this into no, not that. I need 3, and I put shift I. No. Oh shit. Ah shit. Okay, whatever we want virtual. And we want to delete the rest of the stuff. Okay, that should be good. Okay, we can also remove this part. Put and put X. And this, I think these are the actual virtual addresses, and we also have the converted physical addresses, and we can add that into this. Let's just put paste them here, and virtual virtual. Okay, that should be good. Now, okay, let's get back here. So let's just assume that this is what we have done so far. So what we have is that we have allocated space for all the three structures, and we also have the physical addresses of those values, and we also have mapped the page, and we also have the which queue, and we are calling the init. So let's go into it, and here we are setting up those values. Finally, we want to init those registers, and this is where we want to actually write to those registers. So what we want to do is that if we get back to the specification, okay, we will come back here later. Placing available buffer into, okay, okay, let's just go back to, what is it, if we come here and we can, oh shit, just copy this, and yeah, this is what we want to. So we want to write to those addresses, and we already have the offsets. So we take the base plus this offset, and we write the lower 32 bits to low and the higher 32 bits to the high. Okay. I think we don't have to do anything else. Writing to the register selects the which queue that the following operations on applied to. Once we wrote all these values, I guess we can write the index into this cell. Or do we write it first and then we write to these things? What's the order? Do I write to cell first and then I write to the registers, or I write to the register and then I write to the switch it on, start right to the registers. Okay. Okay, here it is. So we have to first of all write to select the queue number, and then we check if the queue that the one we selected is ready or not, and then we write the maximum queue size, and then we allocate the queue memory, and finally now we notify the device by writing the size to queue num, and then we can write the physical addresses of queue description area, driver area, and device area into these register pairs, and finally write one to ready queue. Okay, makes sense. And this is what I was expecting to see, which somehow yesterday I did not see this because I was still wondering what exactly to write and what's the order to write in. Oh, I guess I just had to read the so it's going to be first init queue, and then within init queue I can call init virtual registers. So let me just call init queue first of all. It's going to take which IO objects and also a queue. I need both the things. Yes, it's a queue, fucking queue. What the fuck happened? What else? I think that's it. Nothing much. I can just put a to do here and copy paste this whole thing so we don't forget what we are doing. So first of all we need to select the queue that we are going to write to. So let's say we want to select the 0th index, and we write to queue cell. So it's write U32, and it's going to be a which IO objects, and the offset is going to be which IO queue cell, and this is the offset. And what's the value? We are going to write value as 0, and then we can check if the queue is ready or not. So we just read from queue ready and expect the return value to be 0. Okay, let's do that. So I guess it's going to return a U32 ready stats, and we can have it like read from U32, and it's which IO objects, and what do we have to read from? We read from queue ready. It's going to be which IO queue ready. Where is it? Did I not? Okay, I guess I didn't write that offset. Is it queue ready here? I have queue notify. I don't have queue ready. Okay. It's going to be queue ready 44. Okay. Let's just write that here. And queue ready, and it's going to be 44. Okay. Okay, I guess that should be good. Q ready. Q num max we already have. Q notify we have it. Q num we have it. Q num max we have it. I think we do have everything else, so let's move on. And it is going to be, where is it? Where the fuck is it? Oh shit, I don't have to write this here. I'm supposed to write it here. And let's see, which IO Q ready. I'm reading from this. And if Q ready status equals 0x0, then we can say that, what are we gonna say? We're gonna say that it's ready, but if it's not, then we have to say uart printf. I think I don't have uart here. Okay, let me, I think maybe we can give it a return value. Okay. Okay. Let's just copy it. Let's put it in here, so we'll always have it. And inside our init queue, let's just put uart printf, and it's going to be q z0 is not ready. Why we don't know. Let's just put this and put a return here. Fuck is it showing scribbling? Okay, but once it is ready, we can read the maximum queue size from q num max. Okay, let's just put that again here and paste it and say q max size, and we're gonna read from q max num max. Okay, and if q at this time it's equal to, if it is equal to, then q is not ready because of max size. Okay, this is the second thing. And then what do we do? Now we read the value from here. Now allocate and zero the queue memory, make sure the memory is contiguous. Okay, we have to write 0 into the entire. Okay, it's not that hard. I guess I just have to what's the queue size? Q is a different thing, I guess. I'm looking into where is which Q. this is rich queue, and it has all these stuff. But I mean, it can have multiple stuff like that. That's why we chain them together. Okay, I'm just allocating one. That's not good. And it's just a queue pointer. But queue is a linked list, right? Queue, I think it acts like a linked list. It's just use the next and go, keep going. I don't think we have to allocate it as a one big block. Okay, let's just notify the device by writing the queue size into num. And currently, let's just say queue size is just 1 in our case. Writing the size of the queue num, what does that mean? Should I give the queue overall size, or should I just give the size as the number of queues that it can take? I don't know. Do we have it anywhere? Number of elements in the queue. Okay, I think I'll just write 1 because there is only 1 element. Currently there is nothing there actually. Oh, I don't know. Notify the device about the queue size by writing the size to queue num. But what exactly do I write? Okay, there's only 2 options, so we can try one at a time and see which one works, and yeah, it should be good. Which IO queue num. Let's say 1. I don't know, but yeah. Let's write out comments here. Maybe we have to write the overall size or just count. Write the physical address to the queue's description area, and this is where we are supposed to call our big function that's going to be placed here. And it's going to be init which IO registers. Init which IO registers. And it's going to take which IO objects. And finally we can set the write int ready, and it's just ready, and just write 0x1 and remove this. What? Oh shit. Okay, that's good. Now we have all these steps. We are writing to queue select 0 first of all. That's the index. The first queue index is 0, so we are writing 0. And the status saying that we are right now reading the status saying whether the queue is ready or not, which is the 0th index is ready or not. If it does not say 0, then something is wrong. And then we read the max size of the queue. If it returns 0, then the queue is not available. And then we maybe we have to write whatever we get out in this step and we just write it into here. I don't know. We'll also think about that. Maybe we have to write whatever we get out of the max, nummax, read, and then we have to initialize all the registers. It's just the physical address for queue's description area, driver area, and device area. And finally we write that we are ready. So let's just write this. Okay, so we have, what do we have? We have the description area, so we need to write the upper block into high and the lower block into low. So we still have to think about how to shift it. Higher blocks will be a 32-bit value and the lower block will be 32-bit value. I guess we can shift all the bits to for the lower bits, for getting the lower 32 bits, we simply can zero the upper bits, and then we can just put what is it? We can mark it as U32. And for the upper bits, we can zero the initial bits and then shift everything 32 bits. Okay, that's the two things that we need to do. Okay, it's going to return two 32-bit values. So no, it's just create to help us, so it'll be easy. So it's just going to give you in 32 get lower bits half, and it's going to take a uint 64 value, and we're gonna, for lower half we can simply return it as uint 32, and then we just share and it with 0x f f f f f f f f, and this is the lower half. We want the upper half to be zeros. Okay, so the upper half will be 0 and lower half, if anything is 1, it will stay as 1, and then we return it as uint32. Okay, I think it will work. I think it will work. Now we can debug it later. And then we have the other one. It will be get higher half, upper half. Upper bit should have been better. It's going to be value. Holy fucking moly. Here we have 2 steps. First we need to do the same thing, and it's, let's say, uint64 and temp equal to value and 0x. One, two, three, four, and then 1, 2, 3, 4, 1, 2, 3, 4. So we have 4, 4. So right now we are only keeping the upper bits as it is, and then we can return uint32, and we have to shift the whole thing to right shift the whole thing to 32 bits. Okay, temp. I fucking forgot which is right shift. I think this is right shift. Left should be like this, I guess. Yeah, this is actually, I guess this is the left shift. We are moving all the bits from the left to right. But right now we want to bring the ones from the right to left. So actually we are supposed to do left shift. Yeah, we are actually supposed to do right shift because we are bringing the bits from the right to left 32 times. I think it should work. If not, I'll ask somewhere. And now we can write those registers. What do we do? We have the we have to write, what are the values? We have to write descriptor low, descriptor high. So let's start with that, and we need to copy this. Let's just copy this, and we need to write into which IO descriptor low, and the value is get lower half of which IO objects physical. What? It's correct, right? I don't know. That's the one. So which IO objects, and we have physical which Q dis didn't copy. Okay. What? Which IO object is? Oh, I didn't give type here. Struct which IO star. I guess we have type deft it, so I can just put this. Then we should have. Okay, we shouldn't. We have the access now. Okay, now we can. We got the lower half and we wrote it to the lower half. And we yank it, paste it, and we get the disk high, and we get the higher off upper. That's it. I guess so. If everything goes well, this should be good. Now we can just write the same thing for the other two values, and we can change the things here. It should be Q. What is it? Driver high. Actually, I didn't get those values. Actually, even here, I guess I didn't. Okay, I made it as device avail high and avail low, avail low and avail high, and it should be device used low and used high. Fuck it. Okay. Now we can physical which disk. You can make it as avail and avail. What is it? Used and used here. Okay, good. We wrote all those values, and then we also wrote the register as ready. If these two implementation is not fucked up, I think most of the part should be just fine. Hopefully this is correct. I don't know. Maybe this is fucked up. We are shifting the bits from the right to left. That means it's a right shift operation, because left shift is the one I usually use. We are just moving the bits from here to the left. So what we want is we are shifting the things from the right to left. So the upper bits will come to here. I hope it's correct. Okay. I think it's time to run. Hopefully you don't have any fucked up errors. And we do have some fucked up errors. If we can get past them. I guess we might have to look into these. Convert to physical. What the fuck is that? Okay, that's the one I wrote, the helper. Okay, I have helper only accepts uint64 values. So we can just was it Control V. Let's say we want to write, put this and uint 64. Okay, that should be good. And just move this here. What the fuck happened to V? Pressed insert right. And this one. I think I don't need this one either. Okay. Now let's build it. Okay, now we want to convert those values. This is returning a uint64, but we want a virchaio, so I think we can do is Control V and I, and it should take this and put virchaio star. Okay, how about that? You still have fucking errors? Oh my fucking god. Assigning to wait. What is the type? Oh, it's full of uint64s. Then why the fuck did I mark it as virchaio? The whole thing should be uint64, and this already returns uint64. Fucking hell. I think I'll probably have to convert these three values. And uint64. Okay. Okay. We move past most of the errors and we run it. initio is done, but queue is not ready because of max size. Okay, we have an error. We have an error here. Queue is not ready. When we try to read from this, we got an error saying we actually got this. Okay, wait, first of all, let's see what we got here. UART printf ready status. Let's put D. Oh, okay. I don't have an unsigned integer format specifier. Sorry. Let's just consider it as signed. We simply got 0. Probably even this is not correct. It's definitely possible. Let's just say we want to stop at what do we want to stop? Yeah, we want to disassemble init q, and we want to stop here. Let's jump here, and if we go all the way and we are inside that, now let's try to do that manually. If we go here, where is our initialized location? What the fuck? There's no, oh, it's here. We want to write to this. Let's see what the fuck is inside there. It has some sort of 7472. Is that what we are expecting? Okay, that is correct. 74726976. Okay, that's fine then. Now we want to read device status, and it must be what the fuck is that? Wait, what was the first thing we are doing? We are writing into Q cell, it's /x30. Let's just do that. I don't know if we can write. It's just empty right now. Maybe that's why, just because we read it. Ready? Let's try 44. 44 is also empty. So how the fuck do I know if it actually did something? Let's see. Right GDB break. Set address equal to value. Okay, we can just use set. Okay. Okay, let's see. Set. I want to set this. Equal to value, which is, let's say I want to use index 1. L value. I guess I have to give the type in this. It's int. What? Okay, it's 30. Okay, now if I read from 30, there's nothing there. Maybe it wrote to the upper bits. 38. Okay, I'm fucking the memory now. It's not good. Oh, fuck it. Let's just put 50 here and see every damn thing. Okay, we did write 1. And there is something here. And everything else is zeros. Oh shit. Let's just move past that. Oh, we have a print statement here. Then I'll have to go past that entire UART. And do I have any way to get past it? I think I can just continue. Ah, shit. Do we have to do anything before actually? Let's see. Driver must not access memory locations not described in the driver. Must not write to read-only registers. Must only use 32-bit wide and aligned reads and writes to access the control registers. Okay, must ignore. Okay. There's a lot of musts. Hopefully. Select the 0. I am selecting it as 0. It is taking a UN32 value. Well, let's try 1 then. No harm in trying. Let's see what happens. Still not working. Check if the ready queue is not already in use. Read queue ready. Expect a return value of 0. And in my fucking case, it's fucking always 0. And let's just double check the locations. It is Q cell is 30 and Q num max is 34. Q num is 38. Okay, wait. And what we are doing is we are reading from Q ready. Q ready is 44. writing 1 to the queue register. Okay, that is what we do in the end, because here at the end we say queue ready is 1, but we also read status from here. Oh, that step is fucking walking. And then we are reading from qnum max, and qnum max is not supposed to give us 0 back. qnum max is in 34. And our qnum max is 34. So that is not an issue either. Maybe it's everything is int, that's why it's fucked up. No, but it would automatically convert it to u in 32. Because C does that implicitly, so I don't think that's the issue. No, we do have no idea, no fucking clue. It reads, and we have qnum max, which is just returning 0 all the time, and we check the memory, it's also 0 there. So we are reading it correctly. It's maybe when the device is not updating us properly. Who the hell knows? Or maybe we have a different device. Okay, let's just read the device version. And see what happens there. Device version, and we read from device. We only have device version. Let's just add that here. Device ID and device version. Device version is in 0x. Oh, it's bish.io version. Oh, fuck me. I don't know why the fuck I sometimes put version. Okay. And let's just put another print statement saying version. It's device version. Now we'll kill it. And run it. And device version is 1. Okay, that's the fucking issue. We have legacy. Ah, shit. How the fuck? How do I switch to new version? It's Kemo Maimo Verchayo version shows 0x1. How to switch to version 0x2. Maybe I have to give this. I don't know. Do I have to actually update it via registers? How to specify the brush to use in Kernel? Okay. Hopefully this is not what's it? Hallucinated piece of junk. Hopefully these two values are there. Or it will just say random things to us. Or I could just Google it. If it's there, we should have some examples of it. Okay, so it is true. It didn't fucking hallucinate. Okay. Let's see then. But it just said property which your device disable legacy not found. Maybe we only have this option. We have disable modern off. And again, even that property is not there. You fucking piece of shit. Disable modern. So these two properties are there. But maybe it's for PCI device. For ARM, not PC. It doesn't have PCI, right? Something like that. Dude, I fucking wrote the same fucking thing and I got... We have to use Arch. ARM and Arch are same things, right? In Arch 64. Oh shit. I don't understand what's the difference between BLK device and PCI to enforce. Dude, it just told me that it's fucking not there. Options are not there. Oh, piece of shit. You say it's will automatically enable it, but I am getting it as that. Hmm. Sad. What's my Camo version? Camo. What's the version? It's Camo System Arc version. It's 10.01, so it should have it. I'm Arch 64 Virch IO 2. Oh, fuck me. Oh, maybe I'm writing to the wrong device. No. Let's see. Create a which your PCI device and possibly use. Split into two layers. Transport how which IO device connects to guests, which could be PCI, MIMO. Yeah, so that was the only difference I thought about when I was starting to learn about this. So I thought that ARM-based systems does not have PCI, so we have to use MIMO. I didn't understand anything. Okay, let's move past that. But he said that, but he got issue with some network device, not the. Let's just fucking try it. No. Still nothing. What about the register location? Is it the same? It is the same. Man, this is the one. And we have the interrupt line and the register, and we exited. And version is still 1. Or maybe it's just reading whatever we wrote here. Let's just put 0 here and see what happens. Oh, version is still 1. Okay, then I put PCI here, and then let me add these two. Extra values and see what happens. Legacy on, disable off. Okay. Still not working. Oh, that's which 1.22. What the fuck is a which IO? Okay, let's see. Easy to provide virtual devices to guests. Okay. Standard driver means compatibility across hypervisors and operating system. The purpose of which IO is to ensure that virtual environments and guests have straightforward, efficient, standard fucking blah blah. Okay, we have which IO. That's a completely different thing. BLK is of device type and PCI is the transport layer. Maybe that's why even after I change this, nothing happens. Alright. Or I didn't change it properly. Device type is block and the transport layer is previously used device. Now we have made it as MIMO. What if I put MIMO? Is that even a thing? It's not a valid device model name. We have BLK device. Device disable legacy not found. Huh. We have the descriptor, we have the avail index and the used index. I'm just trying to see if I can manage to understand anything at all. Let's keep this open. Um, okay. I think we have fucking stuck. I have no idea. I have no fucking clue. First of all, one thing that needs to be checked is this. Even this user guide says there is such thing, but when I try to add it, it's not working. Why? Maybe my setup is looking around how to check the current setting of mod lecture or to control it via libvirt. Okay. What the fuck is this? Fucking hell. Looked like an option for something else. I think it's time to check the camel logs. Let's just remove these two. And let's keep it as it was before. And let's just open this, run this, and kill this. CAT camel 1 grep. What do we want to grab for? We want to grab for camel log debugging which I'm not a fucking robot. let's just put virtio and int, and we don't want all. And let's just remove that camo and create it again and build it. What? Did not work. 8. And let's just put your child. What the fuck? There's no fucking thing like which IO that. This is why we should not fucking believe this fucking piece of. Then how do I debug that? Okay. I guess I'll take a break and think about it next week and see what we can do. But right now, let's just write something about what we have done. Looks like we have to change the version of which IO. Currently we are getting version 1, but all implementation is for which IO 1.1, which is 0x2. Maybe we have to find the proper flag, or maybe find the proper device at all. Okay, we'll do that later. Okay. Overall, today we've only managed to write the init queue. But in general, we do have an idea of what exactly we have to write, and we managed to write that part, and we are now able to write to the select, read from the queue. We can also read the version. Yeah, nothing much. Thank you guys. Have a good weekend. Have a good week.